Welcome back to Upward Arrow. I'm Seth Brown, the creator at Upward Arrow, where we believe technology should be beautiful, natural, and sustainable. And my hair does this weird sort of mohawk thing when I'm sleeping, and we're just gonna rock it today, and I hope you like it. Of course, I'm also wearing the Upward Arrow organic cotton t-shirt. Be sure to visit our site and cop one. You're gonna look awesome in it, and I know you're gonna love it. All right, let's get started with the show. This week we're talking about what is a brain-computer interface operating system, and some positive environmental news, of course, as well as some interesting developments going on in neurotechnology in general. So let's dive right in. And the first topic, what is a brain-computer interface operating system? Wow, that's a mouthful. And maybe we should take a step back for those of you that aren't in the neurotechnology community and talk about, well, what is a brain-computer interface? The way that a brain-computer interface works generally is it's a device that acquires signals from the brain, either through detecting electrical signals or using infrared, and in some cases, simply getting an image of the activity of the brain is a type of brain-computer interface. Now, broadly, we're capturing signals or information that's being put out from the brain and the central nervous system. Those signals are captured by a device which again is reading either electrical signals in terms of EEG, infrared signals in terms of FNIR, or simply imagery of blood flow such as fMRI. Now, once those signals are acquired, that information is then sent to a computer or a device for processing, and hopefully there is some sense that can be made from those signals, which then can allow those signals to be used to operate or interface with that computer or device. So broadly speaking, a brain-computer interface device is something that detects signals from the brain or central nervous system, conveys those signals to a computer or other device, which then uses those signals to influence the operation of that computer device or any peripherals that may be attached to it. Okay, that's a brain-computer interface. What about a brain-computer interface operating system? And this is a totally new concept, and no one's really talking about this because everyone's struggling to find out what it really means. As we look across at all the different consumer electronic and clinical devices, invasive and non-invasive, that are available, not surprisingly, we're falling victim to a natural human tendency, which is to map new models onto our old understanding. And you can think of this in a lot of different examples over history. Of course, the easiest example to point to is the horseless carriage, also known as the automobile, which today is known as a car. At the time that it debuted, though, the framework, the mental framework, the concepts that people had in their mind were oriented around the idea of a horse and a carriage. And so the new information was mapped onto that old understanding, hence the automobile or the car was called a horseless carriage. We've got a bit of a horseless carriage going on for some of the softwares that are being developed for brain-computer interfaces. And again, it's a natural human tendency. What's happening is that software developers are using an old or the existing graphical user interface model because it pervades everything. Almost all of our devices in terms of visual interaction are driven by that graphical user interface model, which is from XeroxPARC in the 70s, and even further back if you want to go to Douglas Engelbart or Ted Nelson and his work. Again, depending on how far back you want to look at the origin of that. So the graphical user interface it's old, it's outdated, and it soon will become outmoded. And so what we have now with the current attempts of software for brain-computer interface devices are these mapping onto the old graphical user interface. How can we use a brain-computer interface to move a mouse cursor? Or how can we use a brain-computer interface to type on a keyboard? And Neuralink, which is, and we'll talk about them a little bit later, they've got tons of funding, and their goal is to move a mouse. Now, I certainly understand the digital freedom that would offer someone who's in a locked in or in a neurologically diminished state. However, that is not the ultimate realization of a brain-computer interface. For that, we need to look a little bit more towards the future and understand that direct brain communication or interaction with devices, it's not going to be modulated in the same way as the current interaction with computers that occurs through visual, tactile, and other interactions. That's the mystery we're looking forward to unlocking here at Upward Arrow. As we consider how we interact with the world, many of our interactions are actually quite binary. A light is turned on or off. A faucet is open or closed. A door is locked or unlocked. These very simple binary interactions start to add up to more complex behavior. Not surprisingly, binary interactions or a binary relationship underlies the complexity in computing as well. And so what we're doing at Upward Arrow is we're building a car. We're not building a horseless carriage. We're starting with new models and new ideas. And a brain-computer interface at its core level will operate based on intent. I want to do this, I don't want to do that. And that core binary interaction does not need to be mediated by a graphical user interface. We don't need to use the old models. In fact, we need to let them go. And we need to consider new forms of interaction that are unlocked by the brain-computer interface. Truly, we need to build, in some ways, a highway system. The highway network is what enabled the automobile to spread across America. And so for us, developing brain-computer interfaces, what we need to develop is a new network, a new system of connections between devices and brain-computer interfaces, new freeways to allow the information to flow, and to understand that the primary interaction may not be through a graphical user interface. We've got 5 senses, and some may consider 6 with proprioception, the awareness of where the body is at any given time. Considering that and the core function of the brain at the center of all that, we shouldn't limit ourselves to only a few senses or modes of interaction. So that's a slight window, and it sounds very vague as well. Well, a brain-computer interface is something that's based off of binary interaction. Well, that's not too clarifying. However, we can already consider how something like that may work in practice. For example, to go back to the light and faucet reference, by co-locating an individual near a light switch, the binary intent could then be instantly translated to turn the light on or off. Likewise, when approximating a faucet or a door which needs to be unlocked. Now, the confirmation for these actions doesn't need to occur in any sort of visual feedback other than the environment or the object in the environment changing to meet that intent. So we're eliminating many aspects of traditional computing, or the old models, the horseless carriage. And really, for all members of the neurotechnology community, I would encourage you to think of the car and not the horseless carriage. Okay, we'll talk more about the brain-computer interface operating system in future episodes and what we're up to at Upward Arrow. Let's move on now to some positive environmental news. Now, this is back earlier in the year, although it's great news to share now, and this has to do with carbon capture. Now, in Europe, there is an existing carbon capture firm called Climeworks, and they're amazing. They're sort of the leader in this technology across the world. And carbon capture works by drawing down the carbon dioxide from the atmosphere, also known as carbon sequestering, and then storing it away or turning it into other usable products. Now, the Climeworks solution is great, and they certainly are the innovator in the industry. But here in the United States, at the Pacific Northwest Laboratory, a new method for capturing carbon at factories was discovered or was introduced in January. And what we're talking about is previously it would cost in the thousands of dollars to capture a ton of carbon from one of these facilities or from a factory. And a lot of this has to do with steel production and other heavy industry. This solution from Pacific Northwest Laboratories does this at a fraction of the cost. At $75 per ton. They're able to capture that carbon, and additionally, they're able to create methanol as one of the outputs of their process, further reducing the requirement or further reducing the production of more carbon emissions from mining or generating fossil fuels. So fantastic news that this price has literally gone from the technology costing thousands now to a model that is $75 per ton, which is incredible and shows great promise that we can make a difference when we put our minds to it and we put our effort to it. We can find ways to address the challenges that we're facing and leave a positive impact on the environment. So that's great news. In neurotechnology news, the big buzz since the last podcast episode has been that Neuralink has gotten their FDA approval, which is fantastic. That's great news for all members of the industry. Of course, here at Upward Arrow, we're not too keen on invasive devices, though we do understand the need and how that may benefit certain people. We believe over time, the machine learning and the ability to detect signals will improve to the point that we don't need to crack the skull to get in there and implant electrodes directly. But for now, that's great news for the team at Neuralink and the industry at large. Of course, as we mentioned earlier, we're not 100% behind the approach that they're taking. We believe it's a little bit of a horseless carriage in terms of the ultimate output that they're striving for. Again, we understand why they want to achieve that digital freedom. However, using the old models of interaction may not be the way to go about it. In any event, that's great news for the industry and helps to bring greater awareness around brain-computer interfaces to the general public as we continue to do so here at Upward Arrow. Thanks for watching. We hope you enjoyed it. Of course, as I mentioned, if you want to get a great organic cotton t-shirt, visit our site, upwardarrow.com. Click on the store link. We also have hats and sweatshirts. Your purchase will support our effort to ensure that technology serves humanity. Thanks for watching or listening. We hope you have a great day.